Welcome to the deep dive.
Great to be here.
So today we're tackling AI from kind of two angles. We've got the very latest news, product releases, company moves, and then we're diving deep into this really fundamental question. How close are we actually to AGI, artificial general intelligence?
Yeah, exactly. We've got a couple of sources. One's like a news roundup, giving us the pulse of what's happened just recently. The other one is more of an essay, really digging into AGI timelines and what might be holding things back right now.
Okay, so our goal here is to unpack all of that for you. We'll pull up the key stuff, try to connect, a specific product launch to the bigger picture, and hopefully help you get a handle on what's going on and why it matters.
Yeah, think of it like zooming in on the details, then zooming out to see the whole landscape. We'll go from like specific features to this big debate about whether AI progress is smooth sailing or if there is some major speed bumps ahead. We'll even touch on some maybe surprising ideas about what current AI is good at and what it really struggles with.
All right, let's get into it. First up, that recent news. Pulling from our first source, it feels like things are just moving incredibly fast on the product side.
Oh, absolutely. One big piece was Google. They've rolled out an enhanced preview of Gemini 2.5 Pro,
Hmm.
and they're really talking up the performance boosts, especially, it seems, in coding.
Yeah, I saw those numbers. A 24-point ELO increase on El Marina and 35 points on WebDev Arena, hitting scores like 1470, 1443. For folks maybe not steeped in these benchmarks, what does a jump like that actually signal?
Good question. So think of El Marina and WebDev Arena as like competitive programming arenas, but for AI models. They test how well models handle different coding challenges. ELO scores borrowed from chess rank them against each other. So a 24 or 35-point jump is, well, it's pretty noticeable. It means Gemini 2.5 Pro is getting significantly better at those tasks, climbing the ladder against other top models.
Well,
And they also mentioned it's doing well on other coding tests, like Aider Polyglot, and even on really tough reasoning benchmarks, like GPQA. So it suggests the improvements aren't just, writing basic code, but maybe more complex problem solving too.
and for developers actually using the API, is there something new there?
Right, yeah. They added this feature called thinking budgets. The idea is to give developers more control, basically. You can set limits on how much compute time the model uses for a task.
Ah, so you can balance cost versus how fast you need the answer.
Exactly, tweak it depending on what your application needs. And it's live now in the,
Windsurf, they do that vibe coding thing, right? Making coding feel more intuitive.
that's them. And suddenly, they couldn't get the newest Claude models directly. Their CEO said they offered to pay for capacity, but Anthropic said no.
Anthropic's official line was something about prioritizing sustainable partnerships, right?
Yeah, that was the public statement. But then Anthropic's co-founder, Jared Kaplan, pretty much confirmed it was because of reports that OpenAI might acquire Windsurf.
Ah, so they didn't want their competitor getting easy access to their latest tech through an acquisition.
Pretty much. Kaplan said, quote, "It would be odd for us to sell Claude to OpenAI." It just shows how the intense competition between these big labs can directly affect smaller companies building on top of them. Access isn't guaranteed.
Wow. Yeah, that's a clear example. Okay, speaking of coding assistants, Mistral's also in the mix, but they seem focused on enterprise customers with a big emphasis on security.
That's right. They launched Mistral Code, is pitched as an enterprise coding assistant, and it's actually a suite of 4 models working together.
Four models.
Yeah, Costrol for code completion, Costrol Embed for searching through code, DevStrol for handling specific developer tasks, and then Mistral Medium for just chatting about the code.
And the big selling point for businesses is deployment flexibility and security.
That seems to be key.
Yep.
They offer cloud, obviously, but also reserved capacity and even an air-gapped on-premises option.
Air-gapped meaning totally disconnected from the internet.
Exactly. Which is huge for companies with super sensitive data.
Hmm.
And crucially, it lets them fine-tune the models on their own private code repositories. But that code never leaves their own secure environment. It's in private beta now for IDEs like JetBrains and VS Code.
Makes sense. Meanwhile, OpenAI isn't standing still on the workflow side. They've got this new connectors feature.
Right, this is in beta. The idea is to let you plug ChatGPT directly into other apps and data sources you use all the time. Think Google Drive, GitHub, SharePoint, that kind of thing.
So you don't have to keep switching between apps.
Pretty much. They mentioned 3 types. One for quick searches within your connected apps, one for deeper research across multiple documents, and another that syncs and pre-indexes your stuff so ChatGPT can access it faster.
The goal seems to be making ChatGPT a more central hub for your personal or work information, like accessing your own code or company knowledge base right there.
Exactly. building personalized workflows without leaving the chat. It's available for their team, enterprise, and edu users in beta right now.
Okay. And quickly, NVIDIA, we usually think chips, but they've got models too. Llama Nematron Nano VL.
Yeah, this one's interesting. It's an open weights vision language model, so it understands both images and text. Its specialty is pulling information out of documents, PDFs, charts, tables, diagrams.
And it's efficient.
Apparently so. Designed to run on just a single GPU, which is pretty accessible. The source says it's top-notch on benchmarks like OCR Bench V2, doing things like answering questions about charts or extracting data from tables accurately. You can check it out via NVIDIA's API preview or on Hugging Face.
Got it. And one last bit of news, legal spat. Reddit suing Anthropic.
That's right. Reddit is alleging that Anthropic trained its AI models, specifically mentioning Claudebot, on Reddit user content without permission and without paying for it, claiming it violated their user agreement.
Which is interesting because OpenAI and Google apparently did strike deals with Reddit for data access.
Correct. So Reddit's asking a court to stop Anthropic from using the data and also seeking damages. Adds another layer to the whole data for training debate.
Okay, wow. So that's a snapshot of the recent flurry new models, intense competition, workflow tools, even lawsuits. It definitely feels like things are humming along.
On the surface, absolutely. Lots of activity.
But let's pivot now, like our second source does, and ask, what does this all mean for the bigger picture? For that fundamental question of, how fast are we really moving towards artificial general intelligence?
Right. And this second source offers a really thoughtful, maybe slightly more skeptical take. The author starts with that great quote, I think it's from Rudiger Dornbusch. Things take longer to happen than you think they will, and then they happen faster than you thought they could.
That feels very relevant to AI right now, doesn't it? The author mentions hearing these wildly different AGI timelines from guests, some saying 2 years, others 20. What's their own take as of now?
Well, their perspective, writing in June 2025, is trying to balance the magic they see in current LLMs with the frustration they feel trying to get them to do what they call normal human-like labor.
Like the examples from their podcast production, rewriting transcripts, finding clips, co-writing, things that seem like they should be doable.
Exactly. And their verdict on those tasks, which they describe as simple, self-contained, language in, language out, is that the models are maybe a 5 out of 10.
Only 5 out of 10, despite how impressive they can seem.
Right. Impressive flashes, yes, but not consistently reliable enough to actually replace the human doing that job. And this leads them to what they identify as a core bottleneck.
Okay, what's the big hurdle, according to them?
It's the lack of continual learning. Their argument is that LLMs fundamentally don't get better at a task over time through practice and feedback in the way a human does. You're basically stuck with the abilities you get out of the box.
So even if you give it feedback in a chat, it doesn't really learn for next time.
Not in a persistent way, no.
Yeah.
You can use system prompts, you can give it explicit instructions in the moment, but it's not like a human intern who gradually figures things out, gets faster, makes fewer mistakes, understands your preferences better over weeks or months.
And they contrast that with what actually makes humans useful employees. It's not just raw smarts, but that ability to build up context, learn from mistakes, pick up efficiencies.
Exactly. They use this analogy of teaching someone the saxophone. A human learns through trial and error, getting feedback, adjusting. But teaching an LLM, they argue, is like this. The student tries, fails, you stop them, write a detailed manual explaining the fix for the next student, and that new student reads the manual and tries fresh.
That sounds incredibly inefficient for actually learning an instrument.
Right. And the author says that giving instructions after failure is pretty much the only modality we as users have to teach LLMs anything. You refine the prompt, give examples, but the underlying model isn't building that deep, tacit skill through practice.
What about techniques like RL fine-tuning, reinforcement learning? Doesn't that involve learning from feedback?
They address that. They say RL fine-tuning exists, but they argue it's not the same deliberate adaptive process as human learning on the job. They use their human editors as an example. The editors just get better. They learn the show's style, the audience, what works, what doesn't, organically, without needing some complex reward function designed for every little improvement.
But the author does acknowledge that models can get better within a single conversation, right? Like if you tell it, that was bad, try this instead.
Yes, that's a key nuance. They say models can get kind of smart and useful in the middle of a session. They can adapt to feedback you give them right then and there. Like in the co-writing example, the model improved after the author basically said, your output sucked. and showed it a better version.
But the problem is...
The problem is that understanding that adaptation is lost by the end of the session. It doesn't stick. The next time you start a chat, it's back to square one in terms of that specific learned nuance.
Okay. So could a really, really long context window be a workaround? Like, just keep the whole history available?
The author is skeptical about that, too. They question if you can really capture rich, tacit experience.
Yeah.
It's all the subtle stuff a human picks up over months just by summarizing it into text in a context window.
Like the saxophone example again, you can't just write down how to play well.
Pretty much. And they mention a concrete example with Claude Code, where it figured out a clever optimization early in a long session, but then later, after the context window had compressed the history, it actually undid that optimization because the nuance got lost in the summary.
Ouch. So this lack of real learning and context building leads the author to push back against a prediction made by some of their guests, Sholto Douglas and Trenton Bricken.
Right. Douglas and Bricken had suggested that even if AI progress totally stopped today, the current tech is good enough that economic forces would lead to significant white-collar automation within 5 years anyway.
But the author disagrees based on this learning bottleneck.
Yes, they argue that if AI progress genuinely froze right now, less than 25% of white-collar jobs would actually disappear.
Yeah.
Sure, some tasks could be automated, but because AIs can't build up context and learn on the job like humans, you couldn't really have them operate as actual employees.
They use their own podcast editor example again, right? Technically, a model could rewrite a transcript, but they still hire a human.
Exactly, because the human learns their style, learns the audience, improves their workflow over time in a way the current models just can't. That lack of continual learning is, in their view, a massive barrier to widespread automation today.
Okay, so continual learning is one major challenge. What about other bottlenecks? The author talks about computer use agents, AIs that can actually use software like we do.
Yeah, this is another area where Douglas and Bricken had a pretty optimistic forecast. They predicted that reliable computer use agents, ones you could tell, go do my taxes, and they'd handle the whole process end to end, would exist by the end of 2026.
End of next year. That sounds ambitious. Is the author skeptical of that too?
They are, yes. They raise several points. First, tasks like taxes can take hours. That means the AI agent needs to operate reliably over a much longer time frame, a longer rollout than current agents typically handle well.
And using a computer isn't just text, it's clicking, seeing things.
Exactly. It requires processing images, maybe video, understanding graphical interfaces. That's multimodal, which needs more compute power. And, critically, they bring up this point about training data.
What about the data?
Well, for language models, we had this massive gift, the entire internet's text data to learn from. But the author, referencing someone called Mechanize, points out we don't have a similarly huge pre-existing corpus of recorded, labeled examples of humans using computers multimodally to achieve complex goals. We're kind of spoiled by the text data we had for LLMs.
So building reliable agents is harder because we don't have the right kind of training data readily available?
That's a big part of the argument. Plus, they add that even algorithmic innovations that seem straightforward later often take a while to develop and perfect. They use the example of the DeepSeek R1 reinforcement learning method for coding. It took about 2 years after GPT-4 came out for that to appear. Solving computer use, which seems arguably harder, will likely take significant time too.
Okay, so that's quite a bit of maybe cold water on super fast progress. But the author doesn't just focus on the negatives, right? They also acknowledge some genuinely impressive stuff happening now.
Absolutely. This is where the tone shifts a bit. Despite highlighting these bottlenecks, they talk about looking at the reasoning traces of the top models like O3 or this new Gemini 2.5, seeing how they actually work through problems.
What do they see in those traces?
They see the models breaking down complex requests, thinking about what the user really wants, having internal monologues, catching their own mistakes, and correcting themselves.
And their reaction is pretty strong.
Yeah, they literally write, it's actually reasoning. They get this feeling that we're making machines that are intelligent. They're not dismissing the capabilities. They see real sparks of something significant there.
Is there a specific example of this sort of baby general intelligence?
Yes, they mentioned giving Claude Code just a vague description of an application, and the model managed to zero-shot a working application.
Zero shot meaning it did it without any specific examples of that particular task beforehand?
Correct. Just based on its general knowledge and the vague spec, the author calls that a wild experience and evidence of, Powered baby general intelligence. It's powerful, it shows understanding, even if it has limitations like forgetting by the next session.
So balancing these things, the real bottlenecks like learning and agents, but also these sparks of genuine reasoning, where does the author land on timelines? They make some specific predictions.
They do, but they frame them carefully as 50-50 bets, stressing that AI progress feels very uncertain, maybe log normal, which we can talk about.
Oh, wait, what's the first 50-50 bet?
First bet. AI can handle the end-to-end process of doing taxes for a small business, as well as a competent general manager could do it in a week. So that includes everything chasing down receipts, emailing people, compiling info, deciding on expenses, getting approvals, filing the forms, the whole 9 yards.
All right, a complex, multi-step, week-long task. Their 50-50 date for that. 2028. Wow. That's not that far off, actually, considering the skepticism about agents just now.
It's not. They sort of position current computer use agents as being like GPT-2 was for language. You see the potential, but there are big hurdles. No data corpus, sparse rewards, long horizons. But they also admit that smarter base models and more researchers focused on it could make progress faster than it happened for language. They're clear, though. This 2028 bet is for reliable end-to-end completion, not just a flashy demo.
Okay, 2028 for complex task completion. What's the second 50-50 bet?
The second one goes right back to that core bottleneck, learning on the job. The bet is AI learns on the job as easily, organically, seamlessly, and quickly as a human does for any white-collar work.
Like the AI video editor example. After 6 months, it just gets your preferences like a human colleague would.
Exactly. That level of organic, adaptive learning. Their 50-50 bet for achieving that is 2032.
2032. Okay, that feels more aligned with their view that continual learning is a really hard problem.
It does. They acknowledge they made a huge fuss about how hard it seems now. But they also point out that 7 years from 2025 when they wrote it to 2032 is actually a long time in AI. GPT-1 was only 7 years prior. So they think it's plausible someone could figure out organic online learning within that time frame, even if the path isn't obvious today.
So we have these potential milestones. 2028 for complex agents, 2032 for human-like job learning. The author describes AGI timelines overall as very log normal. What does that mean here? Bust this decade?
Yeah, basically. A log normal distribution, in this context, suggests the probability of AGI happening isn't spread out evenly over time. Instead, the probability might rise quite steeply relatively soon, say, within this decade peak, and then fall off much more slowly afterwards.
So a higher chance in the next 5-7 years than in, say, 2035 or 2040. Why?
Their reasoning hinges on the current driver of progress, scaling compute. They argue that just throwing more computing power at models, which has worked incredibly well so far, probably hits serious physical and economic limits sometime after 2030. Chip manufacturing, energy costs, etc.
So if scaling can't get us all the way to AGI,
then progress has to rely much more heavily on fundamental algorithmic breakthroughs. And they speculate that the low-hanging fruit in terms of algorithmic gains under the current transformer-based paradigm might get picked relatively soon, maybe by the end of this decade.
meaning if we don't get those big algorithmic leaps while scaling is still boosting everything, progress could significantly slow down later.
That seems to be the implication. It makes the next few years feel potentially very high stakes. If the breakthroughs happen, things could move incredibly fast. If they don't, and scaling taps out, the path gets much harder. That's the this decade or bust idea, loosely speaking.
That's a fascinating, almost urgent perspective. Now, the source article also had comments from other researchers adding more viewpoints.
Yes, which is great. It shows this is an active discussion. For instance, Daniel Kofatajlo chimed in. He actually had a similar timeline for the taxes end-to-end agent milestone around 2028, but he was much more optimistic about continual learning.
Oh, when did he predict that?
He put his bet for solving continual learning, like that AI editor example, at the end of 2028, rather than the author's 2032.
Why so much sooner?
His reasoning was interesting. He connected it to the idea of achieving superhuman coding ability first. If AI gets really good at writing its own code, that could dramatically accelerate AI R&D itself. Finding solutions to problems like online learning might happen much faster if AIs are helping design the solutions.
That makes sense. And AI helping build better AI. Who else commented?
Ryan Greenblatt also shared his thoughts. He agreed on many points, like being skeptical about massive automation right now and having similar median timelines around 2032 for a truly crazy AI world emerging. But he had a key disagreement with the author about RL fine-tuning versus human learning.
What was his take on RL?
He pushed back on the idea that RL is qualitatively different from how humans learn on the job. He argued that humans learn from external feedback, and by reflecting on their own successes and failures and RL, based on feedback and strong self-verification, could in principle do the same thing.
So he thinks the difference isn't the type of learning, but how good AIs are at it currently.
Exactly. He framed the current differences as quantitative. AIs are much worse right now at robust self-verification, really understanding why something worked or failed, and they're far less sample efficient. They need tons more data or compute to learn what a human learns quickly. But he believes these are things RL techniques are actively improving on.
So not a fundamental barrier, just a very large efficiency and introspection gap that needs closing.
That seems to be his view. He also made a neat point. If AIs did match human sample efficiency with similar compute, given the massive scale of current training runs, we'd likely already have wildly superhuman AI. The fact that we don't suggest that Gatchin's sample efficiency is either enormous or bridging it requires way more compute than we think.
Okay, this has been a real journey. We started with the tangible new features, company rivalries, actual products hitting the market this week.
Yeah, the stuff that shows clear, undeniable progress on certain fronts. Better coding, better document analysis, more integrated workflows.
But then we stepped back and dove into these deeper, maybe more challenging questions raised by the second source. What are the fundamental roadblocks? Is the lack of true human-like continual learning a major bottleneck? How hard is it really to build agents that can reliably use computers for complex tasks?
And we heard one perspective arguing these are significant hurdles, pushing timelines for truly transformative AI, like replacing employees or handling complex jobs end-to-end out to maybe 2028 or 2032 as 50-50 bets, even while acknowledging the baby general intelligence we see glimpses of today.
But it's not a settled debate. We heard counterarguments. Maybe progress on AI coding could accelerate solutions to learning. Maybe current RL methods can achieve human-like adaptation if we bridge the efficiency gap.
Right. It paints this picture of AI as being in this really dynamic, uncertain phase, moving incredibly fast in some ways, but maybe bumping up against some really fundamental challenges in others. And smart people disagree quite strongly about how quickly those challenges might be overcome.
Which leads us to a final thought for you, the listener, drawing from these sources. Considering that idea of log-normal timelines that AGI might be more likely this decade or bust, because the easy games from scaling compute might run out, forcing reliance on harder-to-predict algorithmic leaps. What does that imply? How should you think about preparing for potentially truly crazy outcomes that might not arrive gradually, but perhaps much sooner and more suddenly than a simple linear trend would suggest?
Yeah, it's a provocative question to chew on. Are we on a slow ramp or potentially approaching a very steep cliff?